Hello there and welcome. I'm glad you found your way here to this quiet space. Perhaps you've had a long day, your mind is full of thoughts, or maybe you're simply the kind of person who likes to drift off to deep, gentle wonders rather than counting sheep. Whatever the reason, this journey is for you. You have nothing to do now but rest. Let your mind grow soft, your breathing slow, and your body feel heavy, as if gravity itself has decided to be a little kinder tonight. Because in this quiet hour, we will be wandering among the oldest, most patient beings on our planet, the mountains. We will explore their silent peaks and hidden valleys, not as climbers, but as quiet observers, learning the slow, deep rhythms of stone and sky. Beneath their serene surfaces lie countless quiet mysteries. We will learn how continents drift together in a slow embrace, pushing rock skyward over millions of years. We will discover how water patiently carves canyons, how air whispers through high passes, and how the very bones of the earth are folded and sculpted with an artist's slow hand. We will travel gently from the deepest roots of a range to its sunlit peak. Some of what you hear may spark a quiet curiosity as you drift away. And just before we begin, if these calm explorations help you find a more restful sleep, consider liking and subscribing. It simply helps other wandering souls find their way to this peaceful corner, one sleepy traveler at a time. Now, let's begin. Chapter 1. The patient birth of giants' mountains are not born in a single, violent event, but from a slow, persistent dream of the Earth itself. The planet's crust is not a single solid shell, but a tapestry of massive plates that float on a slowly churning mantle. These plates drift at the speed a fingernail grows, a patient, ceaseless migration across the globe. When two of these continental plates meet, they have nowhere to go but inward and upward. The land slowly crumples like a rug pushed against a wall, folding over itself in vast geological waves. Over tens of millions of years, this gentle, insistent pressure builds the foundation of every great range on Earth, a quiet testament to the power of patience. The mightiest ranges on our planet, like the Himalayas, are born from a continent's slow-motion collision. India was once a separate landmass, drifting northward for over 100 million years on its tectonic journey. Its eventual meeting with Asia was not a crash, but a gradual, relentless merging. The rocks between them had no escape, and so they were slowly pressed, folded, and lifted towards the sky. This process continues even now, with the Himalayas still rising by a few millimeters each year. It is a construction project of epic scale conducted in near total silence, where the only foreman is time itself. Not all mountains are built by the meeting of continents. Some are formed by the gentle separation of tectonic plates. As the plates slowly pull apart, the Earth's crust stretches and becomes thinner, like warm taffy. This thinning allows great blocks of land to tilt and slide downward, while others remain standing. The blocks that stay elevated become what are known as fault block mountains, with long, rugged ridges and one steep, dramatic face. They are not pushed up, but rather are the parts left behind as the landscape gently falls away around them. They stand as quiet sentinels over the valleys they have watched form. The most iconic and solitary mountains are often volcanoes, born from the Earth's deep internal heat. Beneath the crust, the mantle rock can grow so hot that it melts, becoming a fluid magma that is lighter than the surrounding stone. This magma slowly migrates upward, pooling in vast chambers deep underground. Over centuries, the pressure builds until the magma finds a weakness in the rock above, a pathway to the surface. When it emerges, it is not always with violence. Sometimes it simply oozes out as thick lava, cooling layer by layer into a gentle, sloping cone. Each eruption, whether dramatic or quiet, is a single breath in the mountain's long life. We do not always know why a volcano chooses its specific location, but many arise at the seams of the world. The Ring of Fire, a great horseshoe-shaped belt around the Pacific Ocean, is a testament to this. Here, dense oceanic plates slowly dive beneath the lighter continental plates in a process called subduction. As the descending plate sinks deeper into the hot mantle, it releases water which lowers the melting point of the surrounding rock. This newly formed magma then begins its slow, buoyant journey upward, feeding the volcanoes that dot the coastline. It is a slow, cyclical process of destruction and creation, where one plate's descent gives birth to another range's ascent. Some mountains are built not from the edges of plates, but from hotspots, persistent plumes of exceptionally hot magma rising from deep within the mantle. As a tectonic plate slowly drifts over this fixed hotspot, the magma can burn through the crust, creating a chain of volcanoes. The Hawaiian Islands are a perfect example of this. Each island in the chain is a mountain that was born as the Pacific Plate moved northwest over the hotspot. The island of Hawaii, the youngest, is still being built today, while the older islands to the northwest are slowly eroding back into the sea. It is a conveyor belt of mountain birth and decay, operating over millions of years. The very rock that forms a mountain tells a patient story of its birth. Sedimentary rocks like sandstone and limestone are composed of countless layers of ancient sand, silt, and the shells of tiny sea creatures compressed over eons. When these layers are caught in a tectonic collision, they are slowly folded and lifted from the sea floor to become the peaks of mountains. In the high Himalayas, you can find fossils of marine animals, a quiet reminder that the highest place on Earth was once the bottom of an ancient ocean. The mountain, in its grandeur, is a library of the Earth's deep past. Its pages written in stone. The immense pressure of mountain building can transform rock without melting it, a process known as metamorphism. Deep within the growing roots of a mountain, existing rocks are subjected to incredible heat and pressure, which causes their minerals to recrystallize. The common rock shale, for instance, is slowly transformed into slate, then phyllite, then shimmering mica schist. Limestone becomes marble. This change is not a quick one. It happens over millions of years as the rock slowly adapts to its new, deep environment. The beautiful folded patterns we see in mountain cliffs are the visible memory of this slow, patient transformation under the Earth's immense, quiet weight. The initial shape of a young mountain range is often sharp and jagged, like the Alps or the Rockies. This is because the forces of uplift are still active, building the land faster than the elements of wind and water can wear it down. The peaks are often tall and spired, the valleys deep and V-shaped, carved by fast-flowing streams. The landscape feels dynamic and rugged because the battle between creation and erosion is still tilted in favor of creation. Yet even this apparent violence occurs on a timescale so vast that to any human observer, it appears as a picture of perfect, silent stillness. A moment frozen in the mountain's long life. The birth of a mountain is never truly over. While the initial collision may last for tens of millions of years, the adjustments continue long after. The Earth's crust, weighed down by the immense mass of the new mountains, slowly sinks into the malleable mantle below, a balancing act known as isostasy. As the mountains erode, shedding their weight grain by grain, the crust will slowly rebound, rising back up in response. This means that even as a mountain is being worn down, it is also being gently pushed up in a slow, counterbalancing dance. The mountain you see is not a static monument, but a participant in a slow, graceful dance with the planet itself. Chapter 2: The Architecture of the Earth. A mountain is much more than its visible peak. It is a structure with deep, hidden foundations. Just as an iceberg floats with most of its mass submerged beneath the water, a mountain has a root that extends deep into the Earth's crust. The immense weight of the mountain pushes the lighter crust down into the denser, malleable mantle below. This creates a bulbous root that can be several times deeper than the mountain is high. This slow gravitational balancing act, called isostasy, is what allows these massive structures to stand in stable, quiet equilibrium for millions of years. The highest peaks on Earth are supported by the deepest roots. Beneath the Himalayas, the crust extends downward for over 50 miles, a profound anchor of compressed rock. This root is not a rigid pillar, but a slowly flowing mass that adjusts over millennia. As the top of the mountain is gently worn away by erosion, the loss of weight causes the entire crust to rebound upward, and the root slowly rises in response. This means the mountain you see is just the visible part of a much larger, slowly dancing form, a hidden partner in the mountain's long, slow performance on the geological stage, the familiar jagged ridge of a mountain range. Known as an arête, is formed by the patient work of two glaciers. Flowing slowly down adjacent valleys, these rivers of ice carve away the mountainsides with immense, gentle force. Over thousands of years, they grind back the rock from both sides, sharpening the land between them into a thin, serrated blade of stone. This narrow ridge, often dotted with rocky spires, stands as a testament to the sculpting power of ice. It is a natural architecture defined by absence, a spine of rock left behind after everything else was quietly carried away. The highest point where a mountain can support the growth of trees is known as the tree line. This is not a sharp, drawn border, but a soft, transitional zone where the conditions become too harsh for most trees to survive. The air grows thinner, the winds stronger, and the soil shallower. Above this line, the architecture of the mountain changes from a forested cloak to open alpine meadows, and finally, to bare rock and ice. The tree line is a gentle, living contour, a map of the mountain's breadth, showing where its life-giving capacity slowly fades into the quiet realm of stone and sky. Some mountains are not built from a single peak, but form a vast, high-elevation plateau like the Tibetan Plateau or the Altiplano in South America. These are not formed by simple folding, but by the entire crust being thickened and pushed upward as a massive, coherent block. The resulting landscape is a world unto itself, a vast, flat or rolling highland surrounded by the rugged peaks of younger mountains. This high tableland is a testament to the scale of tectonic forces, which can lift an area the size of a continent thousands of meters into the sky, creating a serene, elevated plain under an immense dome of sky. The gentle, rounded profiles of older mountain ranges, like the Appalachians or the Scottish Highlands, tell a story of profound patience. Once they too were young and jagged, rivaling the Himalayas in their height and drama. But over hundreds of millions of years, the forces of uplift ceased, and the slow, persistent work of erosion took over. Wind, water, and ice have patiently sanded down the sharp peaks, smoothing the cliffs and carving the deep, weathered contours we see today. Their architecture is one of soft edges and long forested slopes, a quiet and dignified old age after a fiery youth. The steepest faces on a mountain are often its cirques. These are great, amphitheater-shaped bowls carved out at the head of a valley by a glacier. As snow accumulated over millennia, it compressed into ice and began to flow downhill. This movement plucked rocks from the head wall, slowly carving a steep, curved cliff. When several cirques form around a single peak, they can carve it into a sharp, pyramid-like horn. The classic Matterhorn is a famous example of this architectural form. It is a structure defined by subtraction, a majestic peak revealed only after the glaciers have done their slow, patient work of excavation. Beneath the surface of a mountain range lies a hidden architecture of fractures and folds. The immense pressures of mountain building do not always lift the rock cleanly. They often bend it, break it, and stack it upon itself. Vast sheets of rock, called thrust faults, can be pushed for dozens of miles over the top of other rock layers. The result is a complex, interleaved structure, like a stack of carpets that have been slowly pushed from one side. This intricate internal geometry is rarely visible, but it forms the deep skeleton of the range, the hidden framework that gives the mountain its strength and its form. The gentle slope of a mountain's lower flanks is often its own creation. As the higher peaks erode, rock and debris tumble down, carried by gravity and water. Over time, this material accumulates at the base, building up a soft, sloping apron known as a talus cone or an alluvial fan. This gently sloping land is the mountain's own gift to the valleys below, a fertile ground built from the weathered pieces of the peaks above. It is an architectural feature built not by uplift, but by decay, a gentle transition zone where the high, rugged world of the peak slowly yields to the softer, living world of the lowlands. We do not always know why a specific peak takes its particular shape, as the interplay of rock type, climate, and tectonic history is deeply complex. Some mountains stand as solitary sentinels, while others are woven into continuous, undulating ridges. Their architecture is a record of countless forces, both creative and destructive, acting over spans of time that are difficult to fully comprehend. Each peak, each valley, each cliff face is a unique expression of the Earth's slow and patient artistry. They are not just landforms, but quiet poems written in the language of geology, standing in silent wonder for us to gently contemplate. Chapter 3. The Slow Sculpting Hands. The most dramatic mountain landscapes are often carved not by the forces that built them, but by the gentle, persistent hands that wear them down. Water, in its many forms, is the master sculptor. It begins with rain, a soft touch that falls for millennia, slowly dissolving the chemical bonds in rock. This water seeps into tiny cracks and fissures, freezing and expanding with a gentle, relentless force. Over countless cycles of day and night, summer and winter, this patient work prizes grains of sand and fragments of stone from the solid face of the mountain, beginning the long, slow return to the sea. A river at the bottom of a valley is not merely flowing water. It is a ribbon of liquid sandpaper. The water itself carries suspended silt and clay, which act as a gentle polishing agent against the riverbed. But its true carving power comes from the rocks and boulders it drags along its bottom during times of high flow. These stones tumble and roll, grinding against the bedrock like a slow mechanical rasp. Over thousands of years, this abrasive action can carve deep, V-shaped gorges and smooth, U-shaped valleys, sculpting the very foundation of the mountain with the patient persistence of a flowing stream. The highest peaks are often shaped by the slow river of ice, known as a glacier. A glacier is not a static block of ice, but a river that flows imperceptibly slowly, sometimes moving only a few centimeters a day. Its immense weight gives it the power to grind the underlying bedrock, scouring it smooth and plucking entire boulders from the mountainside. As it moves, the rock fragments trapped within its base act like the teeth of a giant file, carving deep striations and grooves into the stone. The glacier is a quiet, powerful artist, reshaping entire valleys with its gradual, unstoppable passage. The evidence of a glacier's past work is often written in the smooth, polished bedrock it leaves behind. As the ice finally retreats, it reveals a landscape transformed, broad U-shaped valleys, deep, clear lakes scooped out from the bedrock, and long, winding ridges of debris called moraines. The rock surfaces are often smooth to the touch, marked with parallel scratches that point in the direction of the ice's long vanished flow. These are the glacier's fingerprints, a lasting signature of its patient sculpting, a reminder of a time when the valley was filled not with air, but with a slow, creeping river of ice. Wind. 2 is a sculptor of stone, though its work is often more subtle. In high, arid mountains where there is little vegetation to hold the soil, the wind can lift fine particles of dust and sand and carry them vast distances. When these airborne particles encounter a rock surface, they act as a gentle, persistent sandblaster. Over centuries, they can polish rock surfaces, carve intricate hollows, and shape isolated stones into curious, mushroom-like forms called ventifact. The work of the wind is a whisper against the stone, a patient etching that reveals the softest parts of the rock. Grain by tiny grain, the architecture of a mountain is constantly being softened by the gentle hand of soil creep. On every slope, the thin layer of soil and weathered rock is slowly, imperceptibly moving downhill. Triggered by the freeze-thaw cycles of water, the burrowing of animals, and the simple force of gravity, the entire skin of the mountain is in motion. This movement is so slow that it is invisible to the human eye, perhaps only a millimeter per year. Yet, over millennia, it rounds sharp ridges, fills in small depressions, and slowly, gently pulls the mountain down, grain by grain, toward the waiting plains. Water does not only sculpt from the outside, it also carves from within. Rainwater, slightly acidic from absorbing carbon dioxide in the atmosphere, percolates down through cracks in limestone bedrock. It slowly dissolves the rock, enlarging fissures into vast, hidden worlds. Over hundreds of thousands of years, this process can create intricate cave systems, complete with stalactites that drip from the ceiling and stalagmites that rise from the floor. These hidden cathedrals are the mountain's secret architecture, a negative space carved by the patient. Dripping persistence of water working in darkness, the distinctive, layered appearance of many mountain cliffs is a testament to the differing hardness of their rocks. Softer layers of rock, like shale or sandstone, erode more quickly under the gentle assault of rain and wind. Harder layers, like quartzite or granite, resist this weathering and form the bold, projecting cliffs and capstones. This differential erosion creates a stepped or banded appearance on the mountain side, a visual rhythm of strength and weakness. The mountain reveals its own history through this slow unveiling, its internal structure made visible by the patient hands of the elements. The slowest sculptor of all may be life itself. Lichens, tiny symbiotic organisms of fungus and algae, are often the first to colonize bare rock. They secrete weak acids that slowly break down the mineral surface, creating the first tiny particles of soil. Mosses follow, then grasses and shrubs, their roots prying into microscopic cracks and widening them over generations. A fallen tree can pull up a root plate of rock and soil, subtly reshaping the slope. This biological weathering is a quiet, collaborative effort, a partnership between life and stone that slowly prepares the mountain for a softer, greener future. We do not always know the original form of a mountain, for its sculpting began the very moment it was born. The peak you see today is not a finished work, but a single frame in a film that spans millions of years. It is a temporary balance between the slow inward forces of uplift and the persistent outward forces of decay. The wind that whispers through the high passes is carrying away invisible dust. The rain is dissolving minute quantities of rock, and the glacier is flowing grain by grain. The mountain is not a static monument, but a conversation, a slow, graceful dance between the earth's inner fire and the gentle, sculpting hands of the sky. Chapter 4. The Whispering Rocks. Some of the oldest rocks on Earth are not found in the lowlands, but high in the cores of ancient mountain ranges. These are the whispering foundations of the continents, known as cratons. These vast, stable blocks of crust have survived for billions of years, avoiding the tectonic recycling that consumes the ocean floor. Within them, zircons, tiny, durable crystals, have been found that are over 4 billion years old. They are the Earth's oldest known solid materials, time capsules from a world we can scarcely imagine. They hold secrets about the planet's violent infancy, secrets they whisper only to those who listen with the most patient of instruments. The presence of marine fossils on the highest peaks was one of geology's earliest and most profound mysteries. The skeletons of ancient sea creatures nestled in limestone at the summit of Everest quietly testify to an impossible journey. We now understand this as evidence of the immense power of plate tectonics, which can lift the deep sea floor to the roof of the world. Yet, the full story of that journey, the precise path of the ocean that vanished, the exact timing of the collision, remains partially unclear. Each fossil is a quiet puzzle, a reminder of a world map that has been endlessly and slowly redrawn. Some mountains sing, or rather, they emit a low, persistent hum, a vibration too low for human ears to hear. This infrasound is generated by the background noise of the Earth itself, the gentle pressure of winds against slopes, the subtle resonance of the ground from distant ocean waves, and even the slow tectonic grinding deep below. It is a constant planetary music that plays just below the threshold of our perception. Scientists are still learning to interpret this quiet symphony, to understand what these inaudible whispers can tell us about the mountain's structure and the hidden energies moving within it. The theory of plate tectonics elegantly explains how mountains are built, but the precise trigger for their initial formation remains a subject of gentle inquiry. Why did the great supercontinent of Pangaea begin to break apart, setting the stage for the collisions that built our modern ranges? The answers may lie in the mysterious dynamics of the mantle, where vast plumes of heat slowly rise and fall over hundreds of millions of years. It appears that the Earth's interior has its own slow convective rhythm, a deep, thermal heartbeat that breathes life into mountains and then, in time, gently draws them back down. In the high, thin air of the mountain's rocks can develop a dark, mysterious coating known as desert varnish. This thin, shiny film is rich in manganese and iron, and it can take thousands of years to form. The exact process remains a beautiful puzzle. It may be deposited by wind-blown dust and fixed by specialized microbes that live on the rock face. The varnish creates ancient canvases upon which early humans often carved petroglyphs, their stories etched into a surface that was itself slowly created by time and unseen life. It is a collaboration between geology and biology, a patient art project on a stone wall. Some of the most profound mysteries are held in the magnetic minerals locked within mountain rocks. As volcanic rock cools, its iron-bearing minerals align with the Earth's magnetic field, freezing a compass direction in time. Studies of such rocks have revealed that the planet's magnetic poles have reversed themselves hundreds of times throughout Earth's history. The reason for these flips remains one of geology's great unsolved problems: a complex dance of molten iron in the planet's core. The mountains, therefore, hold a silent record of a restless magnetic soul, a navigational history written in stone. The sheer mass of a mountain range is so immense that it gently warps the Earth's gravitational field around it. A sensitive gravimeter would not read a perfectly uniform pull. It would detect a slight increase in gravity over the dense rock of the mountain. However, this increase is often less than expected. This discrepancy, a gravitational faintness, was a key clue to the theory of isostasy and the existence of deep, low-density roots that buoy the mountains up. The mountain's true form is therefore invisible, a hidden structure of lighter rock that extends deep into the planet. Balancing the visible peak, the vibrant colors of mountain rocks are a quiet language of their mineral composition. The rich red of sandstone speaks of iron oxide rusting slowly over eons. The brilliant green of certain slopes may whisper of copper or chromium. The stark white of a marble cliff tells a story of ancient sea life transformed by heat and pressure. Yet, The exact hues and patterns are a complex result of countless trace elements and the specific conditions of their formation. We can read the broad strokes of this story, but the finer details, the subtle whispers of color, remain a deeply poetic mystery. The stability of a mountain slope is a quiet calculation between the strength of its rocks and the persistent pull of gravity. While we understand the basic mechanics of landslides, predicting exactly when a specific slope will fail remains an elusive goal. The internal structure of the rock, its hidden cracks, its water saturation, the subtle clay layers within it, holds the answer. These are secrets the mountain keeps closely, revealed only in a sudden, dusty sigh. It reminds us that what appears as solid and eternal is, on a long enough timeline, simply material waiting to flow downhill, a patient, potential energy. Perhaps the greatest mystery a mountain holds is the origin of the stone itself. Every atom of silicon and oxygen in a quartzite peak, every atom of carbon in a marble slab, was forged in the heart of a long-dead star. That star lived its life and then expired in a colossal explosion, scattering these elements across the void. Over billions of years, this stardust coalesced into our planet and was slowly woven into these towering forms. So when you look upon a mountain, you are not just looking at rock. You are looking at the recycled remains of ancient suns. It is the universe, quietly contemplating itself in a language of stone and time. Chapter 5. The High Atmosphere. A mountain does not merely exist within the weather, it actively creates its own. As winds encounter a mountain range, they have nowhere to go but up. The air is forced to rise, and as it does, it enters regions of lower pressure, causing it to expand and cool. This cooling often causes the water vapor within the air to condense into visible clouds. This is why you so frequently see a cap cloud resting peacefully on a mountain's summit, a soft, white crown formed by the mountain's gentle persuasion of the sky. The peak becomes a silent architect of its own weather, weaving vapor from the invisible into the visible. The lenticular cloud is one of the most serene and sculpted formations in the sky, a sight often mistaken for a silent, unmoving spacecraft. These smooth, lens-shaped clouds form when stable, moist air is forced to flow over a mountain peak. As the air rises and falls in a steady wave on the leeward side of the mountain, the water vapor condenses at the crest of the wave and evaporates in the trough. The result is a cloud that appears stationary, even in strong winds, a delicate ripple frozen in the atmosphere. It is a signature written in the sky, marking the presence of an invisible standing wave of air. At high altitudes, the sun and moon can create quiet, ethereal companions known as sundogs and light pillars. Sundogs, or parhelia, are bright spots of light that appear on either side of the sun, formed when its light passes through a veil of ice crystals in the air. Light pillars are vertical columns of light that seem to emanate from the sun or moon, created by the reflection of light off of slowly drifting, plate-like crystals. These are not solid objects, but gentle illusions of light and ice, a celestial art show painted on the cold, thin canvas of the high mountain air. The clarity of the sky at high elevation is a gift of the thin, dry air. At sea level, the atmosphere is a thick soup of molecules, water vapor, and dust that scatters sunlight in every direction, creating a bright, hazy dome. But on a mountaintop, you have risen above much of this scattering layer. The air is cleaner and more rarefied, allowing sunlight to pass through with less interference. This is why the sky above appears a deeper, darker blue, and why the stars at night seem so much sharper and more numerous. You are simply closer to the void, looking out through a thinner pane of atmosphere. The strange electrical phenomenon known as St. Elmo's fire can sometimes dance on the tips of aircraft wings or mountain peaks. This is not lightning, but a continuous glowing plasma discharge. It occurs when the electrical potential in the atmosphere, often during a thunderstorm, becomes strong enough to ionize the air molecules around a sharp, grounded object. The result is a quiet, crackling blue or violet glow that hovers on the edges of the summit. It is a gentle fire without heat, a visible manifestation of the immense, invisible electrical forces that flow through the atmosphere, channeled by the mountain's patient form. Some of the windiest places on Earth are found on mountain peaks and high ridges. Without the friction of trees and buildings, the wind can flow freely and swiftly. In certain locations, the shape of the mountains can funnel and accelerate this airflow, creating powerful, persistent winds. These winds sculpt the snow into beautiful, wave-like patterns called sastrugi and can shape trees into gnarled, flag-like forms, their branches growing only on the leeward side. The wind is an unseen river, and the mountain peak is a place where you can stand in its current, feeling the full, gentle force of the planet's breathing. The temperature inversion is a quiet meteorological paradox where the air grows warmer, not colder, with height. On a clear, calm night, the ground of a high valley or plateau radiates its heat back into space. The air directly in contact with this cold surface becomes chilled, growing dense and heavy. This layer of cold air then settles in the valley basin like a gentle, invisible fluid. Meanwhile, the air on the mountain slopes and peaks, less affected by the cold ground, remains warmer. From a vantage point above, you can sometimes see the valley filled with a sea of cloud, the cold air made visible, while the peaks bask in the relative warmth of the higher atmosphere. The mountain creates its own gentle rain cycle, a process known as orographic lift. When a prevailing wind carries moist air from an ocean or lake, a mountain range acts as a massive barrier. The air is lifted, cools, and releases its moisture as rain or snow on the windward side. This is why one side of a mountain range can be a lush, green rainforest, while the other side, in the rain shadow, is a dry, high desert. The mountain acts as a great stone gatekeeper, patiently wringing moisture from the clouds and determining the climate of the lands that lie in its gentle shadow. The formation of snow is a quiet act of architecture in the high atmosphere. It begins with a tiny speck of dust, pollen, or even a bacterium carried high into the sky. Water vapor in the supercooled air freezes onto this nucleus, building a crystal molecule by molecule. The specific temperature and humidity at which this happens dictate the crystal's intricate shape, whether it becomes a delicate plate, a long column, or the classic six-armed stellar dendrite. Each snowflake is a unique record of its journey through the clouds, a tiny frozen journal of the atmospheric conditions it gently drifted through on its way to rest upon the mountain. You do not fully understand all the subtle interactions between a mountain shape and the global climate. Massive ranges like the Himalayas and the Rockies act as rocky obstacles that can divert entire jet streams, influencing weather patterns thousands of miles away. The sheer height of the Tibetan Plateau heats the atmosphere above it in summer, creating a massive seasonal pump that drives the monsoon rains. The mountain is not a passive object in the climate system, but an active participant. It is a cornerstone of the planet's weather, a quiet, stone giant that helps to stitch together the tapestry of global winds and rains, one gentle atmospheric breath at a time. Chapter 6. The Long Return to Stone. The moment a mountain peak is lifted towards the sky, it begins its long, gentle return to the sea. This is not a failure, but a natural and peaceful cycle. The very forces that make a mountain tall, the steep slopes and high elevations, also make it vulnerable. Gravity, the patient and constant hand, begins to pull every loose grain of sand and fragment of rock downward. This journey happens slowly, imperceptibly, over millions of years. The mountain does not fall, but rather it slowly settles grain by grain, returning the land to the earth from which it came in a quiet, continuous cascade. The most common end for a mountain is not a dramatic collapse, but a quiet dissolution. Chemical weathering is a subtle process where rainwater, slightly acidic from absorbing carbon dioxide, slowly reacts with the minerals in the rock. Over centuries, it dissolves the bonds that hold the stone together. Feldspar in granite, for instance, slowly transforms into soft clay. This clay is then easily washed away by the next rain, leaving behind the more resistant quartz as sandy grains. The mountain is not so much broken as it is gently unmade, its solid form quietly returning to the earth as dust and sediment. The freeze-thaw cycle is a patient, mechanical sculpture that works in the quiet of the night. Water from rain or melting snow seeps into the smallest cracks and fissures in the mountain's rock face. When the temperature drops, this water freezes. As it turns to ice, it expands by nearly 10%, exerting a gentle but immense force against the walls of its tiny prison. Over thousands of cycles, this persistent pressure prizes rocks apart, breaking large boulders into smaller fragments. It is a slow, rhythmic pulsing of the mountain, a heartbeat of expansion and contraction that gradually reduces solid bedrock to a soft slope of scree. The base of a steep cliff is often adorned with a soft, sloping apron of broken rock known as a talus slope. This is not a random pile of debris, but the mountain's own gentle shedding of its skin. Each fragment on that slope began its journey high above, loosened by frost or root growth, and then tumbled downward. The larger rocks travel farther, while the smaller pieces settle near the top, creating a naturally sorted gradient. The talus slope is a living, breathing landform, constantly being replenished from above, a visible record of the mountain's slow and patient exfoliation. On a long enough timeline, even the hardest granite will slowly flow downhill in a process known as creep. The entire skin of the mountain, the soil, the weathered rock, and the vegetation is in constant, imperceptible motion. Triggered by the freeze-thaw cycle, the burrowing of animals, and the simple, persistent pull of gravity, the mountainside inches downward. This movement is so slow it can only be measured over decades, a gentle, flowing motion of the earth itself. The mountain is not a static monument, but a slow river of stone patiently returning itself to the valleys below. The ultimate destination for most of a mountain's substance is the sea. Rivers act as the great conveyor belts of geology, carrying the finely ground sediment, the silt, clay, and sand, on a long, slow journey to the ocean. There, this material settles in thick layers on the continental shelves. Over millions of years, these layers can be compressed into new sedimentary rock, and in the slow dance of plate tectonics, this rock may one day be lifted up to form new mountains. The dust of an ancient peak becomes the foundation for a future range in a cycle of death and rebirth that spans hundreds of millions of years. The rounded, soft contours of ancient mountains like the Appalachians are a testament to their great age and long submission to the elements. Their sharp peaks and ridges have been patiently sanded down by wind, water, and ice over hundreds of millions of years. They are in the final stages of their return, their dramatic history now written in a language of gentle, forested slopes and quiet, meandering rivers. These old mountains are a vision of peace, a landscape that has settled into a deep and lasting calm, having completed most of their long journey back to the level of the plains. Life itself assists in the mountain's gentle return. Lichens, the first colonizers of bare rock, secret weak acids that slowly dissolve the mineral surface. Plant roots, in their search for water and anchorage, pry apart tiny cracks, widening them over generations. When a tree falls, its root ball can pull up a substantial plate of rock and soil, churning the mountainside. Even earthworms and burrowing animals contribute, constantly mixing the soil and allowing water and air to penetrate deeper. This biological weathering is a collaborative, quiet effort, a partnership between life and stone that slowly prepares the mountain for its next form. The concept of a mountain death is a matter of perspective. While the individual peak may be worn away, its material is never truly lost. The eroded sediments become the fertile soils of distant plains, allowing forests and grasslands to flourish. The minerals dissolved in rivers feed the plankton in the oceans. The mountain gives itself to the wider world, its substance nourishing life and forming new geological foundations. Its end is not an emptiness, but a dispersal, a gentle integration back into the flowing systems of the planet. The mountain becomes the soil, the sea and the air completing its long, quiet return. We do not know the final form of any mountain, for their cycles are intertwined with the restless motion of the earth itself. A range may be worn down to its roots, a flat, featureless plain known as a peneplain. But that same crust, now lightened from its eroded burden, may slowly rise again in a process of isostatic rebound. Or it may be swallowed by the slow march of a tectonic plate, drawn down into the mantle to be recycled, and perhaps, one day, to rise again in a different form. The mountain story has no true end, only transitions, a slow, rhythmic dance of becoming and unbecoming, woven into the very fabric of the planet. Chapter 7. The Unseen World Beneath. A mountain's visible peak is only a small part of its true form, like the tip of an iceberg floating in the crust. Deep beneath the surface, the mountain extends downward in a vast, bulbous root of lighter rock that buoyantly floats in the denser mantle. This root, which can be several times deeper than the height of the peak above, is the hidden anchor that provides stability over millions of years. It is a world of immense, steady pressure and slow plastic flow, a foundational counterweight to the grandeur above, a silent, unseen partner in the mountain's long, patient presence on the earth. Beneath many mountain ranges flows a hidden ocean of fresh water, trapped in porous layers of rock known as aquifers. This water originates as rain and snowmelt high on the slopes, which then percolates down through cracks and permeable stone, filling vast subterranean reservoirs. This slow journey can take centuries, the water filtering through sand and gravel until it is purified. These aquifers are the mountain's secret treasury, slowly releasing their stored water into springs and streams, providing a constant, gentle flow that sustains life in the valleys below, long after the rains have ceased. The most elaborate hidden architectures within mountains are cave systems, carved not by force, but by a patient chemical whisper. In limestone ranges, slightly acidic rainwater seeps through the bedrock, slowly dissolving the calcium carbonate over hundreds of thousands of years. This process enlarges tiny fissures into vast, interconnected caverns and winding tunnels. These are cathedrals of darkness formed drop by drop, where the only sounds are the gentle plink of water and the slow, crystalline growth of stalactites and stalagmites, a hidden world built by the patient persistence of water and time. Deep within the mountain, the Earth's inner warmth makes itself known. The temperature of the rock gradually increases the deeper one goes, a phenomenon known as the geothermal gradient. In some active mountain ranges, this heat can be intense enough to warm the groundwater, creating hot springs that bubble up to the surface. These pools are a direct connection to the mountain's deep thermal energy, a place where the planet's inner fire gently kisses the surface, offering warmth and minerals in a quiet, steaming spring, a soothing breath from the world below. The pressure deep within a mountain root is so immense that it can transform rock without melting it, in a process called metamorphism. Common shale, buried and compressed over millions of years, is slowly transformed into a sequence of new rocks. It becomes slate, then phyllite, then the glittering foliated layers of schist, and under the greatest heat and pressure, the banded beauty of gneiss. This transformation is a slow-motion alchemy. where minerals recrystallize and realign, recording the story of their deep burial in their new shimmering forms, a hidden tapestry woven under the weight of the world. Some of the most breathtaking hidden wonders are the delicate formations that adorn cave ceilings and floors. Stalactites grow downward from the ceiling as mineral-rich water drips and leaves behind a tiny ring of calcite each time. Stalagmites build upward from the floor from the same dripping water. Their growth is a testament to immense patience, often accumulating at a rate of just 1 centimeter every 100 years. These silent stone icicles are the mountain's internal artwork, a slow-dripping sculpture garden created in perfect darkness over hundreds of millennia. We do not know the full extent of the life that exists in the deep, lightless realms within mountains. Beyond the reach of the sun, in cave waters and deep aquifers, exist unique ecosystems fueled by chemical energy rather than photosynthesis. Chemosynthetic bacteria can derive their sustenance from minerals like sulfur or iron dissolved in the water. These microbes form the base of a food web that can support strange, specialized creatures, colorless, eyeless shrimp, transparent fish, and delicate albino spiders. This is a hidden biosphere, a world of quiet, alien life thriving in the perpetual night beneath the stone. The mountain itself breathes in a slow, geothermal sigh. In volcanic regions, gases like carbon dioxide and radon, produced by the decay of radioactive elements deep in the crust, slowly percolate up through fractures and pores in the rock. This steady, invisible exhalation is a reminder of the dynamic planet below our feet. While usually harmless in the open air, these gases can sometimes accumulate in low-lying areas or poorly ventilated caves, creating invisible pockets of the mountain's deep breath, a silent testament to the ongoing subterranean processes that shape our world. The network of fractures and faults within a mountain acts as its hidden circulatory system. These are not signs of weakness, but rather the natural adjustments of a massive structure under stress. They provide pathways for water to travel deep into the aquifer, for geothermal fluids to rise, and for cave systems to form. They are the pores and veins of the mountain, allowing for the slow exchange of fluids and gases and the gradual plastic flow of rock under pressure. This intricate hidden fracture pattern is the subtle architecture that allows the mountain to live and breathe as a dynamic part of the Earth. The world beneath the mountain remains one of the least explored frontiers on our planet. The immense pressures, total darkness, and complex labyrinthine passages make it profoundly difficult to access. We have mapped the surfaces of other planets in greater detail than we have mapped the vast aquifers and deep cave systems beneath major mountain ranges. What other life, what mineral formations, what secrets of the Earth's history lie in those uncharted depths remains a beautiful mystery. The mountain keeps its deepest secrets well, holding them in a quiet, dark embrace. A hidden world waiting patiently in the stone. Chapter 8. The Human Pilgrimage for Millennia. Humans have felt a quiet call to journey toward the high places. This is not merely a physical challenge, but a form of pilgrimage. The act of walking a mountain trail step by slow step creates a natural rhythm that stills the mind. The path itself, worn smooth by countless feet over generations, becomes a thread connecting the traveler to those who walked before. With each ascent, the noises of the everyday world gently fade, replaced by the sound of breath and wind, creating a space for deep contemplation and a personal, quiet reverence for the scale of the stone around you. The oldest mountain trails were not built for recreation, but were woven into the landscape by the slow, patient passage of animals following seasonal migrations. Early humans, observing these paths of least resistance, began to use and widen them, creating the first trade and communication routes across high passes. These trails are a collaboration between instinct and necessity, a network etched into the land long before maps existed. To walk them today is to follow an ancient, invisible guidance, a whispered direction from the animals and ancestors who first found the gentle way through the rocky slopes. High on remote peaks and sheltered in quiet caves, monks and hermits have often sought solitude for centuries. They built simple monasteries clinging to cliffsides like Tengboche in the Himalayas or Meteora in Greece. The thin, clear air and the immense, silent presence of the mountains provided a perfect backdrop for meditation and prayer. The mountain was not an adversary to be conquered, but a temple of stone and sky, a place to step away from the world in order to listen more closely to the quiet voice within, a sanctuary for the soul. The simple act of building a cairn is one of the oldest human gestures in the mountains. These small, deliberate piles of stone serve as silent guides along a trail, especially when the path vanishes over bare rock or in a mist. But they are more than just markers. They are a quiet form of communication between travelers, a way of saying, "I was here, and the way is this way." Each stone placed is a gesture of care for those who will follow, a small, human-made harmony within the vast, natural disorder of the scree-filled slope. The practice of leaving offerings on mountain summits is a tradition found in cultures across the globe. From the summit cairns of Scotland to the high passes of the Andes, people have left small stones, ribbons, or personal tokens. This is not an act of litter, but one of humble reciprocity. It is a quiet thank you to the mountain for safe passage, a gesture of respect for the spirit of the place, or a way to leave a personal burden behind in the expansive, cleansing air. It is a human whisper of gratitude woven into the fabric of the peak. For many, the mountain pilgrimage is a journey that begins long before the first step is taken on the trail. It starts with the sight of a distant blue peak on the horizon, a silent, persistent presence that calls to something deep within us. This pull is a form of nostalgia for a place we may have never been, a longing for perspective, and a simpler, more elemental world. The mountain represents a challenge, yes, but more importantly, it represents a quiet clarity, a place to remember that we are small, yet part of something vast and enduring. The view from a summit is often described as panoramic, but its effect is deeply personal. After hours or days of focused attention on the trail at your feet, the world suddenly opens into an immense, silent vista. This shift in perspective can gently quiet the internal chatter of the mind. Personal worries, when held against such a scale of space and time, often seem to soften and lose their sharp edges. The mountain does not solve problems, but it offers a quiet space where solutions can drift in, as gently as a cloud on a still afternoon. We do not fully understand why the human spirit feels so restored by time spent in the high mountains, but the effect is deeply felt. The combination of physical exertion, clean air, and the sheer beauty of the landscape seems to quiet the nervous system. The Japanese practice of Shinrin-yoku, or forest bathing, finds its ultimate expression in the high alpine, where the air is scented with pine and the only sounds are natural ones. It is a sensory immersion that gently washes away the fatigue of modern life, a pilgrimage back to a more natural, quiet rhythm. The descent from a mountain is as much a part of the pilgrimage as the ascent. The body is tired, but the mind is often clear and refreshed. The return journey is a gentle reintegration, a carrying of the mountain's quiet perspective back into the world of the everyday. The memory of the vast silence, the clarity of the air, and the feeling of smallness under the wide sky becomes a personal touchstone. It is a quiet resource to be drawn upon long after the boots are put away, a lasting echo of the mountain's peace, carried within. The human connection to mountains is ultimately a story of quiet reverence, not domination. While some seek to conquer peaks, many more seek simply to be in their presence, to absorb their patient, enduring energy. A mountain does not care if we climb it, but it offers its gifts freely to those who approach with respect. The gift of perspective, the gift of stillness, the gift of remembering our place in a much larger, older, and beautifully silent world. It is a relationship built on awe, a pilgrimage that always, in some way, leads us back to a more peaceful center within ourselves. Chapter 9. From molehill to mountain. There is no single, universal definition of a mountain. It is a concept shaped by perspective and local context. Geologically, it is often defined as a landform that rises at least 1,000 feet above its surrounding area. But this is a human metric, a convenient line drawn on a map. In a flat plain, a small hill can feel mountainous, while a foothill of a great range may be dismissed. The essence of a mountain is not just in its height, but in its prominence, its steepness, and its ability to create its own world of climate and life. A kingdom of stone that stands apart from the land around it. The smallest mountains on Earth are mere wrinkles in the landscape, often the worn-down roots of ancient colossal ranges. These monadnocks or inselbergs rise gently from otherwise flat plains, the last stubborn remnants of rock that have resisted erosion. They may only rise a few hundred feet, yet they possess the same essential qualities as their giant cousins: a distinct summit, their own microclimate, and a sense of isolated prominence. They are the quiet elders of the mountain world, their small stature belying an immense and patient history, a gentle whisper of the tectonic forces that once shaped the continent. The highest peaks on Earth, like Mount Everest, are not the tallest mountains when measured from their true base. The island of Hawaii is the summit of a single, immense volcanic mountain that rises from the floor of the Pacific Ocean. From its base on the seabed to its summit at Mauna Kea, it stands over 33,000 feet tall, quietly dwarfing Everest's 29,000 feet from sea level. This perspective reminds us that most of a mountain's structure is hidden from view, a submerged foundation that speaks of the immense, slow forces building the planet from the ocean floor upward. Our solar system hosts mountains that make even the greatest earthly peaks seem like gentle hills. On Mars, the volcano Olympus Mons is the tallest known mountain in our solar system. It stands 16 miles high, nearly 3 times the height of Mount Everest. Its slopes are so gradual that a person standing on its surface would not be able to see the peak, as the curvature of the planet itself would hide it. It is a monument to a world without plate tectonics, where a volcanic hotspot could build a single, gentle giant for billions of years, a quiet titan on a rust-red world. The forces that build mountains operate on a scale that is almost impossible to perceive. The tectonic plates that carry continents drift at roughly the same speed your fingernails grow. This gentle, ceaseless migration, just a few centimeters each year, is enough to crumple the Earth's crust into ranges that scrape the sky. Over 10 million years, this slow drift can move landmasses hundreds of miles. The mountain is a patient creation, a sculpture formed by the softest, most persistent of pressures, a testament to the power of incremental, barely there motion accumulated over deep time. From the perspective of a tiny insect, a single rock on a mountainside is its own mountain range. A patch of lichen becomes a forest, a trickle of dew, a mighty river. At this scale, the mineral crystals in the granite become towering geometric cliffs of feldspar, quartz, and mica. The mountain is not one entity, but a universe of smaller worlds, each with its own topography and microclimates. This shift in perspective reveals that a mountain contains multitudes, a nested series of landscapes from the continental to the microscopic, all existing in quiet simultaneity. The lifespan of a mountain range spans hundreds of millions of years, a scale that challenges human comprehension. The Appalachian Mountains, now softly rounded and ancient, were once a young, jagged range taller than the modern Himalayas, formed over 480 million years ago. They have witnessed the dawn of land plants, the age of dinosaurs, and the rise of humanity. A single mountain exists through countless generations of forests, the slow drift of continents, and the shifting of climates. It is a patient witness to deep time, a silent clock whose hour hand moves once every million years. We do not know the exact number of mountains on Earth, for the definition blurs at the edges. There are likely hundreds of thousands of distinct peaks, if not more, from the named giants to the unnamed, anonymous rises in remote wilderness. Each one, whether it is a celebrated summit or a quiet hill in a forgotten valley, is a unique expression of geology. Each has its own story of formation and erosion, its own place in the hydrological cycle, its own small world of life clinging to its slopes. The planet is a tapestry of these rises and falls, a quiet, rumpled landscape of stone. The perception of a mountain's scale is deeply influenced by the air through which we view it. On a hazy day, a peak can appear distant, soft, and dreamlike. On a crystal-clear day, that same mountain can seem to leap forward, its details sharp and imposing, feeling intimately close. This atmospheric lens constantly reshapes our relationship to the scale of the landscape. The mountain itself does not change, but our human experience of its grandeur is filtered through the ever-shifting, invisible ocean of air that surrounds us, a gentle reminder that our perception is always a collaboration with the elements. In the grand, cosmic scale, even the tallest mountain is a temporary and minute feature. On the surface of a planet that is itself a speck, orbiting an average star in a remote corner of a galaxy, mountains are the delicate, fractal wrinkles on a world. Yet for us, they represent the ultimate in terrestrial grandeur and permanence. This contrast is the heart of their poetry. They are minuscule in the universe, but colossal in our human experience. They teach us humility by their scale, and they teach us awe by their beauty, a perfect balance of perspective held in silent, stone repose. Chapter 10. The Pulse of the Seasons. A mountain's year is not marked by months on a calendar, but by the slow, vertical migration of life and temperature. This is the pulse of the seasons, a gentle, rhythmic breath that expands and contracts with the sun's angle. In spring, the warmth creeps up the slopes, waking the dormant wildflowers in the meadows. In autumn, the cold air slowly descends, painting the deciduous leaves in fiery hues before drawing a blanket of silence back over the land. The mountain does not experience seasons as a flatland does. It lives them as a vertical gradient, a slow tide of change washing up and down its stony shores. The annual snowpack is the mountain's most visible and vital seasonal clock. Each winter, snow accumulates in the high basins, layer upon layer, like the pages of a book being slowly written. The weight of new snow compresses the old, and the unique temperature conditions of each storm create a hidden stratigraphy of crystals and ice. In spring, this frozen reservoir begins its slow release, melting into streams that will water the valleys for the entire dry season. The snowpack is the mountain's long, patient exhalation, a life-giving breath of water stored in its frozen lungs through the winter. The tree line is not a fixed wall, but a soft, living contour that breathes with the rhythm of the seasons. In summer, its edge is a vibrant zone of hardy, wind-sculpted trees and alpine flowers. In winter, it is a stark boundary between the sheltered forest below and the exposed, snow-swept alpine world above. On a grander scale, over centuries, the tree line may slowly shift its position in response to a changing climate, creeping upward during warmer periods or pausing in its ascent during colder times. It is a dynamic frontier, a slow-motion wave of life responding to the Earth's long-term thermal tides. The cycle of freezing and thawing is the dominant rhythm of the high alpine, a daily pulse that sculpts the very ground. Water seeps into the soil and rock fractures during the day, At night, it freezes and expands, lifting and shifting the earth in a process known as frost heave. This gentle, relentless churning creates unique patterns on the ground, circles of stone, striped fields of gravel that look like the artwork of the earth itself. It is a slow, mechanical heartbeat that breaks down rock, sorts sediment, and constantly rearranges the surface of the high country. The mountain's wildlife moves to the quiet, insistent drum of the seasonal pulse. As the snow line retreats in spring, herds of elk or mountain goats follow the fresh vegetation upward, grazing in high meadows only accessible for a few short months. The marmot emerges from its long hibernation, and the pika busily gathers grasses for its winter hay pile. In autumn, this migration reverses as animals follow the descending line of warmth and food back to their sheltered winter ranges. Their lives are a quiet, instinctual dance with the mountain's seasonal breath, a synchronized movement up and down the slopes. The quality of light on a mountain changes with the seasonal rhythm, painting the stone in different palettes throughout the year. The low-angled sun of winter casts long, deep blue shadows and bathes the peaks in a soft, rosy alpine glow. The high, direct sun of summer washes the slopes in a bright, clear light, revealing every detail of the rock. The autumn light is golden and rich, highlighting the colors of the changing foliage. This shifting light is the mountain's mood, a slow, visual music composed by the Earth's tilt and its journey around the sun. The soundscape of a mountain is a symphony conducted by the seasons. In spring and summer, it is a chorus of melting snowmelt rushing in streams, the buzz of insects and the calls of birds. In the deep of winter, a profound silence often falls, broken only by the wind or the soft thump of snow sliding from a branch. The transition between these soundscapes is gradual, a gentle fading in and out of life's audio track. To sit quietly on a mountainside is to listen to the year turn, to hear the planet's slow and patient breathing through the medium of sound and its absence. The growth rings of a high-altitude tree, like the ancient bristlecone pine, are a library of the mountain's seasonal history. Each narrow ring represents 1 year of the tree's life, and the width of the ring tells a story of that year's conditions. A wide ring signifies a long, warm growing season with ample moisture. A series of narrow, tight rings speaks of years of drought or persistent cold. By reading these patterns, scientists can reconstruct the climate of the mountain for thousands of years into the past, a chronicle of good years and lean years written in the patient language of wood. We do not fully understand all the subtle triggers that coordinate the high-altitude bloom, but the result is one of nature's most fleeting and beautiful rhythms. For a few short weeks after the snow melts, the alpine tundra erupts in a carpet of wildflowers. These plants have adapted to complete their entire reproductive cycle in a window of mere weeks, racing against the return of winter's chill. Their brilliant, concentrated bloom is a celebration of the brief summer, a riot of color and life that seems to pulse with urgency before the long sleep returns, a soft, vibrant exhalation on the high, thin soil. The seasonal cycle is ultimately a story of storage and release, a rhythm of accumulation and surrender. The mountain stores water as snow and releases it as life-giving streams. It stores solar energy in the summer rock and releases it as residual warmth on an autumn night. It stores the carbon of the atmosphere in the wood of its forests and releases it back in the slow decay of winter. This gentle, planetary metabolism is the true pulse of the mountain, a slow, balanced rhythm of giving and receiving that has continued, uninterrupted for millions of years, a quiet, steady heartbeat of the earth itself. Chapter 11. The Silent Force of Gravity. Gravity is the silent, unseen architect of all mountain landscapes, a gentle but persistent force that never rests. It is the pull that gives a peak its stature, drawing every atom of rock toward the planet's center. This constant attraction is what gives a mountain its presence, its weight, its grounding in the world. Yet, this same force is also patiently working to pull it down. From the moment a peak is lifted up, gravity begins its long, slow work of return, a quiet dialogue between uplift and decay that shapes every cliff and valley. It is the background hum of the planet, a force both creative and destructive in its patient embrace. The immense weight of a mountain range causes the entire crust to sink gently into the malleable mantle below, in a balancing act known as isostasy. Think of the crust as a series of wooden blocks floating in water. A thicker, heavier block will sink deeper, but will also float higher. As a mountain grows, its deep root forms, and the entire landmass settles into a new equilibrium. This is not a one-time event, but a continuous slow-motion dance. The mountain floats on a fluid interior, its visible height perfectly counterbalanced by its deep, unseen foundation, a testament to gravity's quiet, balancing hand. The most dramatic evidence of gravity's work is a landslide, but even this is often a slow, patient process. While some landslides occur suddenly, many are what geologists call creep, where entire slopes inch downward over centuries. Water seeps into the soil, lubricating the grains and adding weight, allowing gravity to gently tug the mountainside toward the valley. This slow, flowing motion is invisible to the eye, but over time it can tilt trees, bend retaining walls, and gradually soften the mountain's profile. It is gravity's whisper, a persistent suggestion that everything, in time, must flow downhill. The graceful, curved shape of a hanging valley is a quiet signature of gravity's differential pull. A smaller, shallower glacier in a tributary valley lacked the mass and weight to carve as deeply as the main trunk glacier below. When the ice melted, the smaller valley was left suspended high on the mountainside, often with a waterfall cascading from its lip. This architectural feature is a frozen record of gravity's greater influence on the larger, heavier river of ice which carved a deeper path in its patient, downward journey. The gentle pull of gravity dictates the final resting place of every grain of sand and every weathered boulder. On every slope, there is a specific angle, known as the angle of repose, which is the steepest slope at which loose material can remain stable. This angle is different for sand, gravel, or large boulders. When material is piled steeper than this angle, gravity will gently cause it to slide until it finds stability again. The soft, conical piles of scree at the base of a cliff are a perfect example of this, a collection of fragments that have found their peaceful, gravitational equilibrium. The very rock within a mountain is under constant, gentle stress from gravitational forces. This pressure, over millions of years, can cause solid rock to slowly fold and flow, a process known as plastic deformation. Deep within the mountain root, where temperatures and pressures are high, the rock behaves less like a brittle solid and more like a thick, slow-moving fluid. It adjusts and contorts to distribute the immense weight, creating the beautiful, flowing patterns seen in metamorphic rocks like gneiss. This is gravity's patient, internal sculpture, a slow rearrangement of the mountain's very bones. We do not always know the precise trigger that will cause a stable slope to finally release in a rock slide, as the internal structure of the mountain holds its secrets. The stability is a complex interplay of the rock's strength, the presence of water, and the orientation of hidden cracks and layers. A slope can remain poised for centuries, held in a delicate balance, until a single, heavy rain or a small tremor provides the final, gentle nudge that gravity requires. It is a reminder that the mountain's form is a temporary balance, a quiet truce that can be softly broken at any time. The force of gravity extends its influence beyond the solid rock, governing the flow of every river and stream. Water always seeks the lowest point, and gravity provides the gentle, unceasing pull that guides it on its journey. The path a river takes down a mountain, its meanders around resistant rock, its waterfalls over hard ledges, is a direct map of gravity's persistent work. The river is gravity's liquid instrument, carving the landscape according to its silent, unwavering direction, patiently finding the path of least resistance back to the global sea level. The gentle force of gravity even plays a role in the slow continental dance of plate tectonics. At subduction zones, a dense oceanic plate slowly sinks back into the mantle, pulled down by its own negative buoyancy. This gravitational sinking is one of the key driving forces behind the entire tectonic cycle. It is this slow, deep descent that helps pull the rest of the plate along and creates the space for new crust to form elsewhere. The majestic mountains built by these collisions are, therefore, indirect children of gravity, their birth initiated by this gentle, relentless pull in the dark, deep places of the earth. In the end, a mountain is a temporary monument to a balance of forces. The inward force of tectonic uplift builds the land skyward, while the outward force of gravity patiently works to level it. The mountain you see is the current, quiet expression of that equilibrium. It is not a static object, but a slow event, a performance in which gravity is both the stage and the conductor. It is a reminder that stability is not the absence of force, but a beautiful, prolonged, and gentle standoff between the Earth's inner fire and its silent, constant pull. Chapter 12, The Oldest Sentinels. The Appalachian Mountains in eastern North America are among the most ancient ranges on Earth. Their formation a story whispered from a time before the dinosaurs. These softly rounded peaks are the weathered roots of mountains that once rivaled the Himalayas in their grandeur, forged in a series of colossal continental collisions over 480 million years ago. The very rock you walk on there has witnessed the assembly and breakup of supercontinents, a silent, stony memory of a world map that has been entirely redrawn. Their current gentleness is a testament to the patient, billion-year-long work of wind and water. Some of the oldest individual rocks on the planet are found not in the lowlands, but cradled within the hearts of ancient mountain ranges. In the Canadian Shield, within the worn-down roots of long-vanished mountains, lie crystals of zircon that have been dated to over 4 billion years old. These tiny, durable minerals are time capsules from the Hadean Eon, when the Earth's surface was still a molten, violent landscape. They are the closest thing we have to the original crust of our planet, and they now rest quietly in the north. The ultimate sentinels of deep time, the Ural Mountains in Russia stand as a quiet, weathered spine between Europe and Asia. They are the fossilized suture zone of an ancient ocean that closed over 300 million years ago, merging two ancient continents into one. The forces that built them have long since stilled, and now they exist as a gentle, forested range, rich in mineral treasures like gemstones and iron ore. These mountains are the quiet, forgotten seam of a continental union so old that it predates the flowering plants, a stitched scar on the planet's surface that has softened with age. We do not know the exact contours of the Earth's first mountains, for they have long since been ground back into the mantle. But their legacy may live on in the cratons, the vast, stable interior cores of the continents. These geological shields, like the one in Western Australia or Scandinavia, are the foundational blocks upon which all later geology was built. They are the surviving fragments of the earliest, most stable crust, the unyielding anvils upon which younger mountain ranges were later forged. They are the quiet, unshakable elders of the continental family. The Caledonian Mountains, whose roots now form the highlands of Scotland, Norway, and parts of Greenland, tell a story of an ancient Atlantic Ocean that opened and closed long before our modern Atlantic was born. These mountains were built in a colossal collision between the ancient continents of Laurentia and Baltica, around 400 million years ago. Today, their separated remnants stand on opposite sides of a new ocean. Silent, distant cousins whose shared stony DNA tells geologists of their former connection. A broken family of peaks remembering their past unity. The story of the Earth's atmosphere is written in the banded iron formations found in the cores of ancient mountain ranges. These distinctive rust-red layers of rock were formed over 2 billion years ago, when Earth's early oceans were rich with dissolved iron and the atmosphere had little oxygen. As the first photosynthetic bacteria began to produce oxygen, it reacted with the iron in the seawater, causing it to precipitate out and settle on the seafloor in thin, rhythmic layers. These bands are now lifted high in mountains, a quiet stone chronicle of the planet's first great breath of oxygen. The Great Smoky Mountains, draped in their characteristic blue haze, are among the oldest mountains on Earth, part of the larger Appalachian system. The haze itself is a soft exhalation of the vast forests that cloak them. Volatile organic compounds released by the trees scatter blue light from the sun, creating the smoky, dreamlike atmosphere. This haze is a collaboration between the ancient, unyielding stone and the vibrant living forest upon it, a veil that has shrouded these old peaks for millions of years, adding to their aura of deep, timeless mystery. The concept of deep time finds its most profound expression in these ancient, weathered ranges. To stand in the Appalachians is to stand on a landscape that has been a forest, a desert, a shallow sea, and a towering alpine range, all over the course of hundreds of millions of years. The mountain does not experience time as we do. It is time made tangible. Its slow erosion is the ticking of a geological clock, each grain of sand a moment falling away, reminding us that our human history is but a single, soft breath in the long life of the stone. Some of the most ancient mountains on Earth have been worn down so completely that they are now nearly flat plains, known as peneplains. These vast, low-relief landscapes are the final stage in the erosion cycle, the ultimate victory of gravity and weather over uplift. In places like parts of the Canadian Shield or Western Australia, you can walk for miles over exposed billion-year-old bedrock, a surface that was once the core of mighty peaks. It is a landscape of profound peace, the quiet, almost silent epilogue to a mountain's long and dramatic story. The oldest mountains hold the memory of life's earliest experiments. Within their folded layers in rocks like the Burgess Shale in the Canadian Rockies are found the exquisite fossils of the Cambrian explosion. These are not the bones of dinosaurs, but the imprints of soft-bodied, alien-looking creatures that swam in ancient seas over 500 million years ago. The mountains, in their uplift, have preserved these delicate snapshots of life's first, bold diversifications. They are not just monuments of geology, but libraries of biology safeguarding the fragile, early chapters of the story of life itself. Chapter 13. The Future of the Range. The future of any mountain is a gentle but inevitable descent. The forces of erosion are constant, and once the tectonic forces that built a range fall silent, the patient work of decay becomes the dominant story. Over millions of years, the sharp, jagged peaks of young mountains like the Alps or the Rockies will be softened, their cliffs rounded and their valleys widened. They will slowly come to resemble the gentle, forested slopes of the ancient Appalachians, as wind, water, and ice continue their quiet, persistent work of smoothing the rough edges of the world. The Himalayas, the youngest and most dramatic of the world's great ranges, are still actively rising, pushed upward by the ongoing collision of the Indian subcontinent with Asia. This uplift will not continue forever. Geologists believe the tectonic forces will eventually slow and cease, perhaps in another 20 million years. When that happens, the immense range will begin its long, slow surrender to gravity. The peaks will stop their ascent, and the relentless scouring of the monsoon rains and glaciers will begin to patiently reduce the highest place on Earth to a landscape of softer, lower hills. The slow dance of the continents ensures that new mountain ranges will be born long after current peaks have faded. The East African Rift Valley is a place where a continent is slowly being pulled apart, a process that may, in 50 million years, open a new ocean. The edges of this new sea will eventually collide with other plates, crumpling the land and giving rise to future mountain ranges that do not yet have a name. The planet's tectonic engine is always turning, promising that the story of mountain building is a cycle without a final end, only new, slow-motion beginnings. We do not know the precise timeline, but the relentless pull of gravity and the constant fall of rain guarantee that all mountains will eventually be worn down to a nearly flat plain, a peneplain. This is the theoretical end stage of erosion, a vast, low-lying landscape where rivers meander slowly over a bedrock that was once the core of mighty peaks. In this distant future, the dramatic topography we associate with mountains will be gone, replaced by a serene, almost featureless plain, a quiet and level world where the ghosts of giants sleep beneath the soil. The fate of a mountain is also written in the climate of its future. As the Earth's climate shifts, the patterns of precipitation and temperature that drive erosion will also change. A range that becomes drier may see its glaciers retreat and its rivers shrink, slowing the pace of its calving. A range that becomes wetter may be scoured by more intense rains, accelerating its own dissolution. The mountain does not control these forces, it simply responds to them, its future shape being a quiet conversation between the solidity of its stone and the changing breath of its atmosphere. The slow, isostatic rebound of the crust will continue to shape mountains long after they have ceased to rise tectonically. As a mountain is eroded, its immense weight is gradually lightened. In response, the buoyant crust beneath it will slowly rise, like a ship riding higher in the water after a heavy load is removed. This gentle upward float can continue for tens of millions of years, counteracting erosion and prolonging the mountain's life. It is a delayed reaction, a deep planetary memory that refuses to let the mountain go without a slow, graceful, and protracted farewell. In a future hundreds of millions of years from now, the current configuration of continents will have shifted beyond recognition. The Atlantic Ocean may begin to close, bringing the Americas into a gentle collision with Europe and Africa. Such a collision would birth a new supermountain range, a future Appalachians or Himalayas along the suture of the continents. This hypothetical range, which geologists sometimes call the Amasias, would be a new crown for the planet, built from the recycled rock of ancient seafloors and the worn-down remnants of our current mountains. The very rock of the mountains will undergo its own future transformations. The sedimentary particles eroded from today's peaks will be carried to the sea, deposited in layers, and eventually compressed into the sandstones and shales of the future. If these new rocks are caught in a subsequent tectonic collision, they will be heated and compressed, transforming into slate or schist. Some may even be drawn down into the mantle to be melted and reborn as new granite. The mountain's substance is immortal. It simply changes form, participating in the slow rock cycle that has continued for billions of years. The future of specific iconic peaks is a quiet, contemplative study. A mountain like Mount Everest will, in a few million years, no longer be the highest point on Earth. Its summit will be lowered by erosion, and other, younger peaks elsewhere will take its title. The individual form of the peak, so familiar to us now, will be lost to time, blended back into the broader shoulder of the range. Its destiny is to become anonymous, its famous profile softened and eventually forgotten, a reminder that all things, even the greatest, are temporary in the flow of geological time. The ultimate future of Earth's mountains is tied to the fate of the planet itself. In about 5 billion years, as the Sun expands into a red giant, the increasing solar energy will profoundly alter the Earth's surface. The tectonic engine may falter as the planet heats. The intense heat will eventually vaporize the water that drives erosion and may even begin to melt the surface rock itself. In this very distant and quiet end, the slow, graceful cycles of mountain building and erosion will finally cease. The patient dance of stone and sky concluding in a soft planetary sigh. Chapter 14. A tapestry of stone and sky. A mountain is not a solitary entity, but a woven tapestry of interconnected worlds, each thread dependent on the others. The high, wind-swept alpine meadow is connected to the sheltered subalpine forest below, it which gives way to the montane woodlands, all the way down to the lowland foothills. This vertical stacking of ecosystems known as life zones is a direct result of the mountain's creation of its own climate. Each zone has its own community of plants and animals, yet they are all stitched together by the flow of water, the migration of animals, and the slow drift of seeds on the wind, a single living garment draped over the shoulders of the stone. The water that defines a mountain biome begins its journey as snow and ice at the highest elevations. This frozen reservoir is the source of life for the entire tapestry. As it melts, it feeds clear, cold streams that cascade downward, oxygenating the water and carving channels through each life zone. These streams provide drinking water for animals, moisture for roots, and a habitat for insects and fish. The health of the high, sterile-seeming snowfields directly determines the vitality of the lush forests far below, a hydrological thread, connecting the summit to the base in a continuous liquid ribbon of life. The soil of the mountain is a living, breathing membrane that holds the tapestry together. It is not merely dirt, but a complex mixture of weathered rock, decomposing leaves, and a vast, unseen network of fungal mycelium. These mycorrhizal fungi form symbiotic partnerships with the roots of nearly every plant, acting as an extension of their root systems and helping them absorb water and nutrients from the stony ground. This hidden fungal web connects tree to tree, flower to grass, in a quiet, cooperative network that underpins the entire visible forest, a secret internet of life beneath the soil. The phenomenon of seed dispersal creates a gentle, constant dialogue between the different levels of the mountain tapestry. Seeds from a high alpine flower may be carried on the fur of a marmot to a lower meadow. A nut from a pine tree in the montane forest might be cached by a jay at a higher elevation, potentially establishing a new tree line. The wind carries the spores of ferns and the seeds of dandelions, sowing life in unpredictable patterns. This constant, slow migration of genetic material ensures the resilience of the biome, allowing life to slowly adapt and shift its boundaries in response to a changing world. The mountain's tapestry changes with the seasons, a rhythmic pulse that synchronizes life across all elevations. The arrival of spring does not happen all at once. It is a slow, green wave that travels up the slopes. As the snow melts at the base, flowers bloom and insects emerge. Weeks later, the same wave of life reaches the higher zones, triggering the emergence of animals from hibernation and the blooming of alpine flowers. This coordinated vertical progression is a dance directed by the sun, with each species playing its part in a sequence that has been perfected over millennia, a slow, annual reawakening of the entire system. The trees of the mountain forest play a vital role in weaving the tapestry of the sky to the earth. Their canopies intercept rain and cloud moisture, which then drips gently to the forest floor, reducing erosion. Their fallen needles and leaves create a soft, absorbent duff layer that acts like a sponge, holding the meltwater and releasing it slowly into the streams. The trees also generate their own humidity through transpiration, contributing to the clouds that often shroud the peaks. They are not just inhabitants of the mountain, they are active participants in creating and sustaining its very atmosphere and hydrology. We do not know all the intricate relationships between the countless species in a mountain biome, but each plays a role in maintaining the balance. The pika gathering grasses for its hay pile is also dispersing seeds and fertilizing the soil. The bear, turning over rocks in a stream to catch insects, is aerating the gravel for fish spawning. The hummingbird pollinating a fireweed flower is ensuring the continued presence of that color on the slope. Every creature, from the smallest soil microbe to the largest elk, is a thread in the fabric, and the removal of any one thread can subtly weaken the strength and resilience of the whole. The boundaries between life zones are not sharp lines, but soft, transitional areas known as ecotones. These are the most dynamic and diverse places in the mountain tapestry. The tree line itself is a vast ecotone where forest gives way to tundra. Here, plants and animals from both zones intermingle, and unique species adapted to the edge conditions can thrive. These transitional zones are areas of experimentation and exchange, where the tapestry is most complex and richly woven, a testament to nature's preference for soft edges and gradual change over rigid, defined borders. The interconnectedness of the mountain tapestry means that a change in one area can create a ripple effect throughout the entire system. A landslide on a high slope can dam a stream, creating a new wetland in a valley. A wildfire that burns through a dry montane forest can open the canopy, allowing sunlight to reach the forest floor and stimulate the growth of new, diverse vegetation. These disturbances are not necessarily destructive. They are often a natural part of the mountain's long-term story, processes that reset the stage and allow for new patterns to be woven into the ever-evolving tapestry. In the end, the mountain, its life, and its climate are one inseparable system. The stone dictates the shape of the land, which creates the climate, which determines the life that can grow, whose roots and decay, in turn, shape the stone. The water that carved the valley fell from clouds that were seeded by the trees that grow in the soil made from the weathered rock. It is a closed loop of immense beauty and complexity, a self-sustaining tapestry where every element is both a cause and an effect. The mountain is not a landscape with life upon it. It is a landscape that is alive, a single, breathing entity of stone and sky. And now the stars begin to dim behind your thoughts. The vast, silent peaks we have wandered together are receding into the soft landscape of your mind. We have drifted through nearly 150 quiet truths about these ancient beings, from the patient birth of giants in the planet's crust to the slow sculpting hands of ice and wind, to the long return of stone to dust. You have wandered through hidden caves and high atmospheres, traced the pulse of the seasons, and felt the silent, constant pull of gravity. You have stood with the oldest sentinels and gazed toward the slow-motion future of the range. And in this quiet moment, it is good to remember that you are a part of this tapestry, not just an observer but a participant. The calcium in your bones was once part of ancient limestone seabeds lifted high. The oxygen in your lungs was cycled through the needles of high alpine trees. The water in your cells has fallen as rain on 1,000 mountain slopes, and the very atoms that form you were forged in the heart of a star that lived and died long before our sun was born. You are the mountain remembering itself. Tonight, as you rest, the great ranges continue their slow, silent work. The tectonic plates drift at their fingernails' pace. The snow accumulates in high basins, storing water for the valleys below. The pika sleeps in its burrow beneath the talus, and the bristlecone pine adds another microscopic ring to its 1,000-year life. And you are here, floating within it all, a small, warm presence in the vast, dark quiet, a conscious part of an ancient, breathing world. If your mind is still drifting among these thoughts, that is perfectly okay. Let them go now like autumn leaves released to a gentle stream. There is no need to hold on. Your journey is complete. If you are still awake, you can watch the next chapter another time. But for now, I hope you sleep well and dream softly of quiet slopes and still, high places. Let your breath become slow and your body grow heavy. The mountains are at peace, and so too can you be. Good night.